Okay, let's talk about now problem 6. In problem 6, I am asking you for all the perpendicular vectors. So remember that perpendicular vectors means that the angle between them is a 90-degree angle, no? So when I have two perpendicular vectors are the vectors that have a dot product of 0. So that is a crazy important fact, no? O sea, crazy important. So the dot product A dot B equals 0 if and only if A and B are perpendicular. So like this is a crazy important fact, no? O sea, the cross product is 0 when the vectors are perpendicular. So let us do the dot product of these two guys. Remember, o sea, this fact comes from remember the dot product has two ways of writing it, no? One is that the magnitudes times the cosine, but like if they are perpendicular, then the cosine of 90 is 0, and that is why the dot product is 0. So instead of using this way of writing the dot product, remember that we have two ways of writing the dot product. The dot product of B and W, o sea, the dot product of t, negative 3, t plus 2, negative 6, 7t, is just doing t times negative 6 plus negative 3 times 7 plus t plus 2 times t equals 0. And you solve this, no? O sea, bueno, okay, and you are like, I am hearing you guys, I am hearing you. I am like, okay, Mr. Quichua, so do we end solve them? You can end solve, o sea, like, I have a problem with this equation. Look at this. This is a particular problem of, this is, I'm gonna write it like a limitation of end solve, no? A limitation of end solve is that it only gives you one answer. And that's okay, kids. Don't worry, because there is a way of escaping from this. Because this is a quadratic, I'm just gonna write it down, no? O sea, let us solve it like by hand. So this is what, let us actually solve an equation. Like, don't be a crybaby. Sorry that I am calling you crybabies. Negative 6 minus 21 plus t squared plus 2t equals to 0. This is a quadratic, so this actually has two solutions, no? So this is t squared, collecting these two like terms, plus, minus 14 minus 21 equals to 0. Two numbers that multiply to negative 21 and add up to negative 4, that is t minus 7 and t plus 3. So I have 7 and negative 3. If you've only given me one of the two solutions, I wouldn't give you the total credit. No, this is a quadratic. You can solve quadratics. Okay, now this guy is telling me that the angle is acute for t larger than 7. So because the dot product, o sea, like there is this relation, no? The dot product, o sea, let us look at the graph of this parabola. I have a negative 3 here and a 7 here, no? And this is the parabola that represents A dot B. So, do you agree that this is also the equation of t squared minus 4t minus 21. So, do you agree that for t larger than 7 or smaller than negative 3, the dot product is positive? So what I am observing is that for t larger than 7, and actually, and for t is smaller than -3, a dot b is positive. And for values between -3 and 7, and for t that is greater than -3 and smaller than 7, a dot b is negative. Okay, let me tell you something. So in this note, here I am telling you, if the dot product is 0, I know that the angle between them is a right angle, no? They are perpendicular. O sea, the angle is equal to 90. What happens if a dot b is smaller than 0? So if it is negative, I have that the angle between them is larger than 90. O sea, it is obtuse. And if a dot b is larger than 0, the angle is smaller than 90. O sea, it is acute. And where does this relation come from? O sea, this relation comes from like the fact that a dot b equals to the norm of a times the norm of b times the cosine. Because if you observe, like these two things are always positive, no? So the sign of the dot product is determined by this factor. When the cosine is positive when the angle is acute. The cosine is negative when the angle is obtuse. The cosine is 0 when the angle is 90 degrees. Like, if you want to have something to remember from this problem, is this square, no? O sea, like the dot product tells you, the dot product is used to calculate the angle between two vectors, and the sign of the dot product tells you if the angle is acute, 90, or obtuse. Problem 6. This is a very AAHL problem, no? Which is cool. I think that is cool. No, not a problem from our class, but like an approaches and analysis.